In the previous video we were doing this question and we'll continue that. I was saying that on an object of 10 kilograms, a constant force has been acting for 3 seconds. So we can say constant force has been acting and for time 3 seconds. And it increases the object's velocity from 3 meters per second to 7 meters per second. So what is the magnitude of the applied force? We can say that the acceleration will be v minus u, and here since v is the final velocity, it will be 7 minus 3 since u is the initial one, and by t since 3, so we will have 4 by 3. So acceleration is 4 by 3 meter per second square. But we have to find force. So force is equal to mass into acceleration as we have done in the previous video. So it will be 10 into 4 by 3 which will be 40 by 3 newtons. Since we have done all this in the SI units, we can say that it's in the newtons. So it's 40 by 3 newtons, which is by approximation 16.67 newtons by approximation of course. Or we can say that 16.6 with the bar on 6, which means that 6 is ever continuing, never stops. But it's better to approximate. So now we found the answer of the first part, which was to find the magnitude of the force applied, and now we find the second one. So the second one was that the force was applied for 5 seconds. So let's have the equation. Let's have the values first. So the t would be 5, and as we know the force will be 40 by 3 newtons since we've already established that, and u will be 3 meters per second. So we have to find v. So basically force is equal to ma, so 40 by 3 is equal to 10 into a, since mass is equal to 10 and 40 by 3 is the force. So what will be acceleration? Acceleration will be 40 by 30, which is 4 by 3. This will remain same. Of course, the acceleration will remain same, but up to what extent that would vary. So we need not find the acceleration. The acceleration would only change if the amount of force was changed, not the time. Since the force is considered to be same. Okay, so now we know the time, the force, and the u, the initial velocity, and now we have to find the final velocity. So to find that, what will we do? First, we will relate the given values. So it is known that acceleration will be 4 by 3 of course, and it will be minus u by t, so v minus 3 by 5. So we'll do cross multiplication. So 5 into 4 is 3 multiplied by v minus 3, which will be 20 is equal to 3v minus 9, which means 9 is equal to 3v, which mean that v is equal to 29 by 3. We have an answer here, and which is equal to so it's again an approximation. 9.67 is an approximation since it's a never-ending decimal, and for approximation we use this, and again it comes in newtons. Oh, sorry, it's not in newtons, it will be, as it is velocity, it will be in meter per second. Okay, so we have got the answers. The answers are this for the second part and this for the first part. It's just an idea of what can come in the exam and the tests, but much more difficult questions are known to be asked in Olympiad and so. But of course, one has to start from somewhere. And now you've done that, so we'll now continue our course of the chapter. So for the next thing, we will do the third law of motion. So we will do Newton's third law of motion. Newton's third law of motion is the last law of motion that he had given. So in this, basically, we now know that the first two laws of motion tell us how the applied force changes the motion and provide us with a method of calculating the force. Now the third law of motion states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. These two forces are always equal in magnitude but opposite in direction. These forces never cancel each other but act on different objects and never on the same object. So basically, what does all this mean? Basically, this means in simple words that every action has an equal and opposite reaction. Every action has an equal and opposite reaction. And there's not like conventional forces like they cancel each other, but since these are not like them, these two forces do not cancel each other. Since they do not act on the same object, like when I say they don't cancel each other, I mean that they don't act on the same object and act on different objects. So these forces will be felt to both of the objects. Like when we punch a wall, we exert a force on the wall which the wall exerts on our hand, and these two forces are equal. And so since we exert the force on the wall is also suffering through a force that we now feel on our hand. The pain that we feel is same to the force that we are exerting on the wall. So this was one example. So this third law of motion is as simple as this. So these action and reaction are two opposing forces. And one thing that this law states that there is always a pair of forces and not just one force. Pair of forces. Let's write that. Pair of forces. So action and reaction don't cancel each other since they act on different objects and not on one. These are some characteristics among many. Take a moment to review that. And now for an example. We have already seen that when we punch a wall, the wall and our hand both feel the force. And so when we'll do another example, the game of football. Sometimes when we look at the football and try to kick it with the greater force, it collides with the player of the opposite team. But we both feel hurt because each applies a force to the other. The force which we feel, the force which we apply to the ball applies to us. And when the ball hits another player, the ball applies force to the player which the player applies to the ball. Same forces. So equal and opposite forces. So this was it. Thank you for seeing this video. We'll do the last topic, conservation of momentum, in next videos. Thank you. Continue watching.